We are going to begin Chapter 2, Section 4, Graphs of Tangent and Cotangent Functions. And I want to have you remember the unit circle with tangent and cotangent. Tangent is sine divided by cosine of the angles. So when we are on our unit circle, anywhere that the cosine is 0 would make tangent undefined. Here, let me put it down where you can see it. Anywhere at the 45, sine and cosine, remember, are the same. So the tangent is at 1. So your pi over 4, your tangent is going to be 1. In the second quadrant, the cosine is negative, the sine is positive, so tangent is -1. When we are in the third quadrant, tangent is back to 1, and when we are in the fourth quadrant, then cosine is positive, sine is negative, so tangent is -1. When I have my graph drawn here, I'm counting in pi over 4 increments. Pi over 2, 3 pi over 4, and we're at pi, and you cannot see that green show up at all. When we start graphing these, we know that at pi over 2, we're going to have a vertical asymptote. We know that because the cosine is 0 and it's undefined. At negative pi over 4, pi over 2, sorry, or 3 pi over 2, we are going to have another asymptote. On 0, 0 divided by 1 is 0. At pi over 4, we're at 1, and at the negative, we're down here at -1. So our graph is going to go up the side and down below. And there is your tangent graph. The next thing I want to look at is the domain. If our graph then has asymptotes, vertical asymptotes, then our domain is no longer all real numbers. We have to throw out these asymptotes, and the equation of the asymptotes occur at every pi over 2. We said for our asymptotes, x are equal to that pi over 2 plus it is 1 pi period times k, where k is going to be an integer. The distance between the negative pi over 2 or 3 pi over 2 to pi over 2 is going to be the period. So the period in tangent is now pi, unlike sine or cosine where it was 2 pi. Tangent and cotangent periods are 1 pi or 180 degrees. The domain then is all reals, or x such that x is not equal to, it can't be these asymptotes. So all reals except where those asymptotes occur. And remember, this is set builder notation. You can write those in words if you want to. If you are going to find the exact value of 2 pi over 3, the first thing you have to figure out then, what is the reference angle to 2 pi over 3? Well, pi over 3 is our reference angle. And remember, pi over 3 is at 60 degrees. Sine is radical 3 over 2. Cosine is 1/2. 2 pi over 3 is over here in the second quadrant, and tangent is negative in that quadrant. The sine is positive, the cosine is negative. So you can go ahead and put radical 3 over 2 divided by a negative 1/2. Keep the first fraction, multiply by the reciprocal, and a negative radical 3 is the exact answer for the tangent of 2 pi over 3. When we are looking at our cotangent, the cotangent is cosine over sine. Everywhere sine is 0, you're going to have an asymptote. Our y-axis, and then again back over here at pi, we're going to have our asymptote. When we are looking at the halfway point, or pi over 2, we're at 0. This, by the way, is our x-axis. It's really hard to see in this one. So I'm at 0 here. When I am doing the cotangent graph, the cotangent at pi over 4 is positive, so the 1 is here. And when I get to this side, it's negative. So it looks like a reflection of our, whoops, missed my point. It looks like a reflection of the tangent graph. The domain then is going to be all real numbers except, so x such that x is not equal to the asymptote. So where or how do we get our asymptotes? For cotangent, the domain are those vertical asymptotes at pi. So every pi units, there's going to be an asymptote. So our domain is all real numbers except for those asymptotes where k is an integer. Where k is an integer. And it's important that you go ahead and put this little stipulation of what k is. Sometimes there are odd numbers, so you want to make sure that you distinguish that. Just like the period for tangent is 1 pi units and then it starts over, cotangent is 1 pi unit. When we are looking at the exact value of the cotangent of pi over 3 is that 60 degree here, and we know that our sine is radical 3 over 2 and our cosine is 1/2. When we are doing cotangent, we are going to do cosine divided by the sine, which is radical 3 over 2. We keep the first one, multiply by the reciprocal, simplify, and we have that radical 3 in the denominator, so we need to rationalize the denominator. So the cotangent of pi over 3 is radical 3 over 3.